Well, here is a battery pack that I've received from Component Shop, a very efficient service. It's a company in the UK. There are other battery suppliers. There's Overlander batteries, which I've used several times in the past. This is the first time I've used them. And what I've done is I've bought this to replace the plastic box which takes 6 rechargeable AA cells. I think these are C-size cells in there, and clearly at 2500 milliamp hours it's a lot greater capacity. It's an experiment to see how it works. It should give this a lot better running. That's if I can manage to mount the battery onto the underside. Well, there's space and there's clearance, and the thing I'm using is Velcro stick-on tape. I don't know whether that's going to be strong enough. Certainly I wouldn't send that battery into the air on an electric aeroplane without some additional fixing, but I'm hoping that with a couple of strips of Velcro it might be enough to hold it underneath so I can remove it for recharging. It would be possible to fix it permanently to recharge. The other thing, I've ordered it, you can choose the sort of connector you have, and I've ordered it with a Tamiya standard connector, which is normal on, there's another battery pack that was 7 cell, therefore too high voltage. It also is fitted with a Tamiya connector. But what I intend to do, I could get another Tamiya connector for the other side, then a more standard, is to replace it with these connectors. But I'm just going to add a note of caution. Unless you really are happy about what you're doing with batteries, don't. Just buy a spare Tamiya connector to connect to the motor. Why? It's like having a power supply, mains power supply or any sort of power supply, which is always on. So there's no break between the battery and these wires, always live. So that means, and at a phenomenal current, so that it's powerful enough to explode the battery, set fire to anything. Really dangerous. The reason I'm stressing that is because it would be just too easy for somebody to say, oh, let's just chop that off and chop the connector off, and in the very chopping you're going to risk injury. So don't just chop the connectors off. Each wire has to be treated very separately and always kept apart. And for that reason, if you were considering replacing the connector, then on the battery side it needs to be the socket end, because you don't want any way that a stray piece of metal could short circuit or short the terminals together. And that end would go on the motor end. It's a plug which would go in. So I'm doing that partly because I've not got a spare Tamiya plug except on a charger that I want to keep on there. So the thing I would say, having just raised those notes of caution, which I hope you've understood, is don't change connectors, just buy the mating socket or plug and connect that to the motor side. Right, we'll see how that goes. So, well, it may be obvious, but cut one wire first. I've cut the red wire in this case. That leaves the black wire safely insulated inside there. I can strip the red wire and insert it into here, and then having got the red wire safely in there and insulated in a reasonable way, I can then cut the black wire and insert it. So one wire at a time. Right, well, the battery is installed. The weak point is actually the self-adhesive sticking to the matte black painted underside. I think it sticks better to a gloss surface, so I may have to apply adhesive to the Velcro. Just two things. One is, it's still a little bit noisy. I mean, that may be a prototypical sound. I need to tie the wires back so that they don't rub on the track or on the wheels. But the other thing, it does reverse okay. Bit better in reverse. Might improve with running in. I'll turn that off. Is no speed control. You see the circuit down here. The potentiometer will be a symmetrical device, so I don't suppose it matters which way around that's connected, but presumably that's looking from the underside of the potentiometer. The chip, there isn't any indication really, and what I did was I attached the chip to the nut so that the numbers or printing on the chip were uppermost, and then you've got the left, middle and right leg, and I've connected it as so. What I can do is unbolt the chip, have a look at see if on the internet there's an indication of what it is, but it's presumably just some regulator chip. It's a very simple circuit regulating the voltage applied, or the current, might be a current control chip, to the motor, regulating its speed. But if I switch it on and adjust the pot, there is no change in speed of the motor, so that's not working. Reverse is okay, but no change in speed. And I'll follow through the wiring through again, but the only thing I can think is that the left and right legs of the chip are connected incorrectly. The middle leg, obviously, there's only one middle leg. So I'll have a look at that and see if I've made a mistake. Right, from the internet I've been able to find the BD677 Darlington power transistors in a package. It's a couple of transistors in a package there. Base collector emitter. There's two versions of it. Anyway, so by putting a variable voltage in the base, we're able to control the current flowing through from collector to emitter, where the motor is connected on the emitter and the power is connected to the collector. So the motor's turning on. So there's a resistor in series with this, so I assume that the voltage coming into the base through the resistor from the potentiometer is so high in relation to the emitter voltage that it's permanently turned on. So the best way I can test this is to not connect the base directly, but the other side of the resistor, connect it down to the emitter, and that I think will be the motor terminal, and see if that then turns off. I don't know if I've got that right, but my assumption is increase the voltage on the base, you increase the current flow down there, collector to emitter, decrease the voltage on the base, and you decrease the current flow down there. Certainly there's no change taking place and current is flowing. So I have checked the circuit, and that's where the pins are. Base is that one which is connected to the centre of the pot. Emitter is connected to the reversing switch in the motor, and the collector, which is the centre pin, is connected to the other end of the pot and to the negative end. So yeah, the collector is connected to the negative emitter. So it might be that this particular chip in this configuration sits beneath the motor and the ground, and the positive goes to the top end of the motor. So yeah, emitter is connected to the motor, that's fine. Collector is connected to in fact negative end as far as this one's concerned, and positive would be at the bottom. That's how it looks, but basically you're controlling the current down there.